this video, I am going to discuss counterexample. A statement is a true statement provided that it is true in all cases. But if you find one case for which a statement is not true, then it is called counterexample. Then a statement is a false statement. In the following example, we will verify that the statement is false statement by finding a counterexample. So let's say, for example, we have here, okay, for all numbers x, we have a problem. The absolute value of x is greater than 0. Letter B, x to the power of 2 is greater than x. Letter C, the square root of x to the power of 2 is equal to x. So let's begin with letter A. But before we solve or answer this one, let me give you some shortcuts when it comes to assigning the values of x. So here we go. We have here the shortcuts. For all x element of real number, use the numbers below for a convenient trial and error method. Let's say we have here integers. We will use integers, positive whole number, 0, negative whole numbers. And we also have to use fractions, positive fractions and negative fractions. Everything you can see here is applicable and is a shortcut to find a counterexample for any cases or equation or any problem. So let's start with letter A. Is the absolute value of x is greater than 0. So obviously we will expect that whatever will be the sign of the x value here, then the output or the outcome must be in positive form. So let's say, for example, we will assign a negative 1 as the value of x. So let's say we have x is equal to negative 1. So we will substitute negative 1 to the x. So absolute value of negative 1 greater than 0. So since negative 1 is inside the symbol of this one, the absolute value, so what we need to do is make this one positive. So 1 is greater than 0. So at this point of time, when x is equal to negative 1, the statement is true for all the time. So have you noticed here that whatever value of x here, as long as the sign is negative, it is always resulting to a positive number here. So let's move forward to the fraction. Let's say we have here x is equal to 1/2. Let's say, for example, so let's substitute 1/2. So we have here absolute value of x is greater than 0. So this one, 1/2 is greater than 0. Is it true? Yes, it's true. So since in fraction we can see here that the result is always greater than 0, so we need to shift our direction. What if we will use 0 as the value of x? So let's say, for example, x is equal to 0. So substitute 0. Absolute value of 0 is greater than 0. So 0 is never greater than 0. That means to say, this is our counter example, because at this time we have proven that the statement is not true for all the time, because when x is equal to 0, the statement will become false. So this will be our counterexample. So I think that's all for letter A. So let's move forward for letter B. Letter B is x to the power of 2 is greater than x. So we have here x to the power of 2 is greater than x. So obviously x to the power of 2 is greater than x, as always. But as of this time, we need to prove that there is at least one element of x that will make the statement false. So we need to find that value of x. So again, we could always use 0 value of x. So let's say, for example, x is equal to 0. So 0 to the power of 2 greater than 0. So 0 to the power of 2 is 0 times 0 greater than 0. So 0 times 0 is 0. Copy, copy. So 0 is never greater than 0. That means to say this will also be our counterexample. So aside from this, aside from 0 as a value of x, we can also use another values just like fractions. So let's say, for example, we have here x is equal to 1/2. So let's substitute 1/2 to here. So 1/2 to the power of 2 is greater than 1/2. So perform from this one. So 1/2 to the power of 2 is 1/2 times 1/2 is greater than 1/2. So simply copy this one. Okay, so multiplying fractions, simply do this one. 1 times 1, 1. 2 times 2, that is 4. So copy, then copy. So at this point of time, we can prove, or we can show that 1/4 is never greater than 1/2. That means to say, we can show that we also have another value of x to make the statement false. So this is also our counterexample. So we have a lot of counterexamples here in letter B. So let's move forward for letter C solution. So letter C problem is square root of x to the power of 2 is equal to x. So let's say here x square root of x to the power of 2 is equal to x. So let's assign a value. If you try x is equal to 0, then substitute the value of x to the root, to the radical symbol. So we have here x 0 to the power of 2 is equal to 0. Square root of 0 to the power of 2, what we are going to do here, so 0 to the power of 2 means 0 times 0, so is equal to 0. So 0 times 0 is 0. So square root of 0 is 0. So the equation is proven true for all the time when x is equal to 0. So what if we will apply the negative or positive whole numbers? So we have here x is equal to positive 1, or we have here 2 or 3, or whatever value you want, as long as it is a positive whole number. So I just advise you guys to use a baby number, or a number that when you use it into a derivation, you will not encounter any difficulties. So let's use 1, substitute 1 to our equation. So when x is equal to 1 to the power of 2, then equal to 1. So 1 times 1, that is 1, that's equal to 1. So square root of 1 is 1. So we have here 1. So it's proven true. So when x is equal to 1, substitute here this one. X to the power of 2 is equal to x, the value of x is 1. So we have here 1 to the power of 2, that means to say 1 times 1, so that is 1. So copy. So the square root of 1 is 1. So the equation is proven true for all the time when x is equal to 1. So I'm pretty sure that the other numbers will also do the same result. I mean, the equation will always be equal when we are using the positive whole numbers. So what if we are going to apply the negative whole numbers? So let's say, for example, we have x is equal to negative 1. So let's plug into the formula. This is our formula here, this one. So square root of negative 1 to the power of 2 is equal to negative 1. So negative 1 to the power of 2 is negative 1 times negative 1. That's equal to negative 1 copy. So negative 1 times negative 1, that is positive, because multiplying the same sign results positive answer. So negative times negative is positive. So that's equal to negative 1. So square root of 1 is 1. Then copy. Then positive 1 is never equal to negative 1. That means to say, when we are going to apply the negative numbers, the negative whole numbers, then we can have our counterexample. So I think this will be our counterexample. We can have a counterexample when x is equal to negative, or when x is equal to negative whole numbers. You can also try by yourself with the fractions. I think that's all for this video. Thank you for watching. I hope you have gained something, and please don't forget to subscribe and like or comment your concern about this video. Thank you so much.